Today we are going to learn how to solve problems involving system of linear inequalities in two variables. Example 12. State three linear inequalities that define the shaded region in each of the following diagram. First, we have to identify equations for three straight lines. Okay, the first one is given x plus y is equal to 8. Okay, the second line is x-axis. The equation for x-axis is y is equal to 0. And the third one is y-axis. The equation for y-axis is x is equal to 0. Now we can write the linear inequality for the first one. Okay, the shaded region is below the line x plus y is equal to 8, and the line here is dotted line, so we have to use less than. So answer is x plus y less than 8. So we have to change the equal sign to less than. Okay, the second, y is equal to 0. The shaded region is above this line. The region above this line, okay, the line is solid line, so we have to change the equal sign to greater than or equal to. So the second answer is y is greater than or equal to 0. Okay, third one. Okay, the shaded regions is below the is on the right of the equation x is equal to 0, and the lines is solid line, so the inequality sign we have to change is greater than or equal to. So the third answer is x is greater than or equal to 0. Question B. The first straight line is y plus 2x equals -4. The second line is y equals -2, and the third one is y-axis. The equation is x is equal to 0. Okay, now we can write the inequalities. For the first one, the shaded region is above this line. Okay, and the line is solid line, so we use greater than or equal to. So the answer is y plus 2x greater than or equal to -4. Okay, second, okay, y is equal to -2. The shaded region is below this line. Okay, the line is drawn using dashed line, so we use less than. Okay, so the answer is y is less than -2. Okay, and the third one, y-axis, x is equal to 0. Okay, the shaded region is on the left. Okay, it's on the left, and the line is drawn using solid line, so we use less than or equal to. So the third answer is x is less than or equal to 0. Example 13. Write 3 linear inequalities that satisfy the shaded region in each diagram below. Okay. Equation number 1 is the straight line which is parallel to x-axis. This straight line passes through y-axis at 5. So this line is y equals 5. Okay. Equations 2. Okay, we have to write on our own. So get 2.0055. Okay, we use the formula y2 minus y1 over x2 minus x1. So 5 minus 0 over 5 minus 0, and we get the gradient equals 1. And the y-intercept is 0. So the equation is y equals x. Okay, equation 3, the straight line is y-axis. So the equations is x equals 0. Okay, now we can write the inequalities. Okay, first one, x is equal to, y equals x. Okay, the shaded region is above this line, and the line is drawn using solid line. So we change the equations to greater than or equal to. So the first inequalities is y is greater than or equal to x, and the second one is y equals 5. Okay, the shaded region is below this line, and the line is drawn using solid line. So we have to use less than or equal to. So the second inequality is y is less than or equal to 5, and the third one is x is equal to 0. Okay, the shaded regions is on the right, and the line is drawn using solid line. So we use greater than or equal to. So the third inequality is x is greater than or equal to 0. See, first we have to identify 3 straight lines. Okay, the first one is y-axis. Equations for y-axis is x equals 0. Okay, this is the second line and third line. For the second lines, we have to write the equations. Okay, first find the gradients. Okay, so get 2 points. Okay, first one 4 0, and the second one is 0 2. So y2 minus y1 over x2 minus x1. So the gradient is negative 1 over 2, and the y-intercept is 2. Okay, we can write the equation now. Okay, y is equal to negative 1 over 2x plus 2. Okay, the third equations. Okay, get another coordinate for another point. 0, negative 4. Okay, the gradients for this line. y2 minus y1 over x2 minus x1. So the gradient is 1. And the y-intercept is negative 4. So the equation is y is equal to x minus 4. Okay, so the second line is y is equal to negative 1 over 2x plus 2. The third equation is y is equal to x minus 4. Okay, now we can write the linear inequalities. For the first one, x equals 0. The shaded region is on the right, and the line is drawn using solid line, so the inequality sign is greater than or equal to. So the first inequalities is x is greater than or equal to 0. Okay, second line, y is equal to negative 1 over 2x plus 2. Okay, the line is drawn using solid line, and the shaded region is above the line, is the region above. So we use greater than or equal to. Okay, the shaded regions is below. It's below, It's below, so we use less than or equal to. So the second inequality is y is less than or equal to negative 1 over 2x plus 2. Okay, and the last one is the line y is equal to x minus 4. Okay, the shaded regions is region above, and the line is drawn using solid line, so we have to use greater than or equal to. So the third inequality will be y is greater than or equal to x minus 4. Example 14. Madam Carol needs to select at most 20 pupils for the choir competition. The number of girls is at least twice the number of boys. A. Write two linear inequalities other than x is greater than or equal to 0 and y is greater than or equal to 0, which represent the condition of selections of competitions. So the first linear inequalities refer to the first sentence. So before that, let us use letter x to represent the number of girls and the letter y to represent the number of boys. So at most the sign is less than or equal to. So the total number of people is less than or equal to 20. So the total number of boys and girls is x plus y less than or equal to 20. This is the first inequality. Okay. Second inequality refer to the second sentence. Second sentence. The number of girls is at least. At least means greater than or equal to twice, 2 times the number of boy. Boy we use letter Y, girls we use letter X. So the second inequality is X is greater than or equal to 2Y. Okay, for this we have to make the Y the subject of the formula so that the region can be marked correctly. So we write, we get 2Y is less than or equal to X. Okay, now B. Draw and shade the region that satisfy the above system of linear inequalities. So we have to plot all the lines and then shade the region. Okay, draw the x-axis, y-axis. Okay, now we draw the first straight line. Okay, we convert into linear equations. X plus y equals 20. Okay, so to draw this line, we have to construct a table and get 2 points. So the 2 points are 0, 20, 0, 20, and 20, 0. Okay, the inequalities sign is less than or equal to, so we have to join the points using solid line. Okay, this is the first line. Okay, and then we draw the second line. 2y less than or equal to x. Okay, we convert to linear equations. 2y equals x and construct the table. We get 2 points, 0, 0, 20, 10, 20, 10, and we join the point using solid line. Okay. Okay, this is the second line, and the third line is x is equal to 0. Okay, which is the y-axis. Okay, and the last one is y is equal to 0, which is the x-axis. Okay, now use letter to mark the regions. Okay, for the first linear inequality, less than or equal to is the region below, so we use letter A to mark the region below this line. A, 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 A. Okay, and then for the second inequalities, 2y is less than or equal to x, so it's the region below the line. So this line, the region below, so we use letter B to mark it. Okay, and the third line is y greater than or equal to 0 is the region on the right, so we use letter C to mark it. Okay, and the last one is y greater than 0, y greater or equals to 0. Okay, is the region above the line, so we use letter D. Okay, above the x-axis, we mark it as D. So the common region is here. So we draw the line to shade the common region. Okay, C. From the graph, determine the minimum and maximum number of girls when the number of boys is 5. So the number of boys is refer to y-axis. Okay, 5 boys. Okay, we draw the dotted line. Okay, so the maximum and the minimum numbers of girls is 10 and the maximum number of girls is 15. Okay, so the minimum number of girls is 10 and the maximum number of girls is 15. Okay, 2. C number 2. Determine whether the condition of the selections are adhered to if 8 boys want to participate in the choir competition. Justify your answer. Okay, if the number of boys is 8, okay, number of boys is 8 is somewhere here, 8. Okay, we draw the dotted lines. Okay, so we get that, we find that this point is outside the shaded regions. So the answer is no, because the value of y equals 8 is outside the shaded region. Example 15. The maximum number of passengers on a train is in a theme park is 30. As a security measure, the required number of adults is always greater than or equal to the number of children. A. Write two inequalities. Write two linear inequalities other than x is greater than or equal to 0 and y is greater than or equal to 0, which represent the given situations. So first, let us use letter x to represent the number of children and the letter y to represent the number of adults. So the maximum, the sign is less than or equal to. Okay, maximum is 30. So that means x plus y is less than or equal to 30. Okay, the second inequality is the number of adults, okay, y, is always greater than or equal to the number of children. Okay, we use x. So y is greater than or equal to x. Okay, B. Draw and shade the region that satisfy the above system on linear inequality. So we have to plot the graph, draw the x-axis, y-axis, and the suitable scale. Okay, now construct the table and get the informations. Okay, 2 points, 0, 30, okay, 0, 30, and another point is 30, 0. Okay, join the point using solid line because the sign is greater than or equal to. Okay, so this is the first line. Okay, then second one is y equals x. Okay, so the first point is 0, 0, and the second one is 30, 30. Okay, we use solid line to join it. Okay, this is the second line. And the third one is x equals 0, which is the y-axis. And the fourth one is y equals 0, which is x-axis. Okay, now use letter to mark the region. Okay, the first one, less than or equal to, so it's the region below. Okay, region below the first line, so we use letter A. Okay. Okay. Second inequality is y is greater than or equal to x. So region above the second line. Okay. So we use letter B, okay, to mark it. Okay, and then the third line is x is equal to 0. Okay, the inequality is x is greater than or equal to, so it's the region on the right, so we mark it as C. Okay, and the last one is y is greater than or equal to 0. Okay, this is the region above the line, so we use letter D. Okay, we use letter D. Okay, where is the common regions? Yes, this is the common region, so we shade the common regions. Okay, question C. From the graph, determine the maximum number of children that is allowed to board the trains. So children refer to x-axis, the maximums. So the maximum, look at these regions. So the maximum for children is 15. So the answer is 15. C. If there are 18 children, can all the children board the train at the same time? Justify your answer. So if the children is 18, is somewhere here. Okay, we use dotted line and fill out that it is outside the shaded region. So the answer is no, because the value of x equals 18 is outside the shaded region. Okay, we have learned how to solve problems involving system of linear inequalities in two variables. Now try exercise self-practice 6.2D on your own. That's all for today. Thank you.